Assalamualaikum and a very good day. I bid to Sir Faris and my fellow classmates. My name is AHMAD FIKRY and my teammates are Muhammad AJRUN bin ZIMON and AHMAD SODIQ bin LOQMAN. We have been given the title of nodal and supernode. So without further ado, let's start with what is nodal analysis. Nodal analysis is the mathematical method for the calculating the distribution of voltage method between the nodes in the circuit. This method is also known as the node voltage method, since the node voltages are with respect to the ground. There are three laws in nodal analysis, which the first one is Ohm's law, second is Kirchhoff's voltage law, and Kirchhoff's current law. Features of a nodal analysis. Nodal analysis is an application of Kirchhoff's current law. So when there are n nodes in a given electrical circuit, there will be n-1 simultaneous equation to be solved. To obtain all the node voltages, n-1 should be solved. The number of non-reference nodes and the number of nodal equations to be obtained are equal. So the procedure of nodal analysis. For step 1, we need to identify the principal nodes and select one of them as the reference node. This reference node will be treated as the ground. Second step is all the node voltages with respect to the ground from all the principal nodes should be labeled except the reference node. Step 3, the nodal equations at all the principal nodes except the reference node should have a nodal equation. The nodal equation is obtained from Kirchhoff's current law and then from Ohm's law. And lastly, the step 4 is to obtain the node voltages. The nodal equations can be determined by the following step 3. Hence, for a given electrical circuit, the current flowing through any element and the voltage across any element can be determined by using the node voltages. The types of nodes in nodal analysis. There are two types of it, which are the non-reference node. Non-reference node is the node that has a definite node voltage is known as the non-reference node. Or the reference node act as a reference point to all the other nodes is known as the reference node, which is also known as the datum node.
Type of reference node. First, chassis ground. Second, earth ground. Next, the supernode is defined as a voltage source that is connected between the two non-reference nodes such that these two nodes form a generalized node. The properties of supernode. First, the difference between the voltage of two non-reference nodes can be determined at the supernode. Second, a supernode does not have its own voltage. And the last, Kirchhoff's current law and Kirchhoff's voltage law both are applied for solving the supernode.
Assalamualaikum everyone and hi. Today I want to explain about the nodal analysis problem. To solve this circuit, we need to know the Kirchhoff current law. Kirchhoff current law is described as the total current that enters the junction equal to the total current that leaving the junction. So in this circuit we know that I1 and I2 is the current that entering the junction, and the I3 is the total current that leaving the junction or leaving the node. So that's why we got the equation of KCL, which is I1 plus I2 equal to I3. We know that the Ohm's law equation is V equal to IR. So from that equation we can get the I equal to V over R. For the I1, the voltage that drop across the resistor 1 is VA minus VB over 15, which is the resistor 1 resistance. As same goes to the I2. And for the I3 is VB minus 0, which is the 0 is the ground, divided by the AT2, which is the resistor 3 resistance. And just doing the basic mathematics, which is sum minus product and balance equation, and we got the 47 VA plus 15 VC, and the VA we just subs with 5 volt, and VC we just subs it with the 6 volt. And we got the value of VB, which is 4.6036 volt. And when we got the VB, we can get all the voltage that drop across all the resistors. For example, the voltage that drop across the resistor 1 is just minus VA and VB, which is 5 volt minus with 4.6036 volt. And then the value that left is the drop, is the voltage that drop across the resistor 1, or voltage that run across the resistor 1. And from there we can get the value of current, which is I equal to V over R. V is the value of voltage that drop across the resistor, and R is the resistance of the resistor. And then we could get the value of the current of I. That's all. Thank you. Assalamualaikum.